difference of two squares on the middle part of your notes. I think it's probably the one you'll remember the fastest because you've seen this before. It's also the one I think is the best shortcut to remember. The good thing about shortcuts is they save you time. Okay. The bad thing about them is you have to be able to recognize when they apply in the first place. And then nobody really ever remembers that, and you have to go to Google anyway, so what's the point? But this one is generally easy to notice and recognize, and therefore the shortcut is beneficial. So difference of two squares is when you have two perfect squares that are being subtracted from each other. By the way, when you see A and B today, it's different from the A and B that we did before, like where we have ax squared plus bx plus c. This A and B is unique for today, so try and don't think about it in previous circumstances. We're using them fresh today. So if you have stuff that's perfect squares that are being subtracted, the formula for factoring it is a minus b, a plus b. So let me show you an example of that. It means you're square rooting the first one, you're square rooting the second one, you're making a minus version and a plus version of them. So in this example right here, factor 25x squared minus 81. Thank you. Oh, yeah. You're going to take the square root of the first term. Okay. What is the square root of 25? 5. And what's the square root of x squared? X, okay. And then step 2 is square root the second term. What's the square root of 81? 9. And then all you're going to do is create two factors with that 5x and that 9. One with a plus and one with a minus. Okay. And if you FOILed that back out, you'd get 25x squared minus 81. The middle terms would drop because the signs are opposite, and you would just have 25x squared and then minus 81. Do you remember that formula from all the other algebras you've ever taken in your life? Yeah. Yes. No? Well, it's a pretty easy one. This is my easy one. One of the easiest ones. All right, so doing this one right here, you're going to do what? Square root both terms. So what is the square root of 16? What is the square root of 16? And what is the square root of x to the 4, do you think? X squared, perfect. It's whatever multiplied by itself will give you back x4. No, there's no catch. What's the square root of 49? 7. And we're going to put them in the parentheses, a plus version and a minus version. But which one am I writing first? The 4x squared or the 7? 4x squared. So it's 4x squared plus 7, 4x squared minus 7. That's it. You try on the bottom practice examples, it's this one B and this one C, but this one has a GCF to pull out first. So pull out the GCF before you do the shortcut formula. So try that for just a second. C, what did you get? Perfect. You square root the first one, square root the second. This gives you 3x. This gives you 8. You just make a plus version and a minus version. Does it matter which order you write those in? Like, could I have taken these and flipped them? Yep. Yes. Because when you're multiplying two things, it doesn't matter the order. That's commutative. Oh, sorry. I don't know if that messed you up. But I don't mean inside. Inside that order has to be that. But I mean the factors, the parentheses could go either way. The actual groups. What GCF did you pull out on B? 4, right? So that's 4 times x squared minus 9. Then when you go to do the formula, the shortcut, you're only doing it on this part. I'll do that too. Let me finish this way, and then I'll show you what you could do if you didn't do GCF first. So now when you square root this and square root this, that's x in 3, and you're going to make a plus version and a minus. Oh, you thought it was a 6. If you didn't do GCF in the very first step, here's how you could fix that at the end. So this is if you didn't do GCF first. If you didn't do GCF first, you would have taken square root. You would have got 2x minus 6. Have a GCF, right?
Yeah.
Each of them. So you would have 2 times x minus 3, 2 times x plus 3. And what is that 2 times 2? 4. You would just have to recognize to do that at the very end instead of at the beginning. Okay. All right, so that one's easy, right? All right, so let's look at the top. This one up here is for also a very specific situation. This is not a rule you can apply to anything, just these very particular ones. What's going on here is, let's look at this example with the numbers first. 4x squared. 4 is perfect square. X squared is perfect. 36 is also perfect. It just so happens that when you square root them, okay, the first one gives you 2x, and the second one gives you 6. I want you to put your eyes up here and look at this pattern real fast. I'll give you some time to write again in just a second. What is 2x times 6? Okay. What is 12x times 2? Okay, that's not a coincidence that that's 24. When you square root this, you get a. When you square root this, you get b. This term in the middle is that a value times the v value times 2. That's where these formulas are coming in, okay? That's the specific situation going on. Well, see, I don't even know if we had any of these circumstances yesterday. In general, it doesn't hold true. In most problems, this won't apply. It just applies in very limited circumstances. So when you have these circumstances, then you can do the formula. The trick is recognizing when it applies and when it doesn't. That's why I don't really like teaching the shortcut so much, because it's hard to remember. So when you have it set up, so what's the only thing that's different between this setup and this one right here? What do you see? There's just one difference. Mm-hmm. Between the first two terms and the first one, this is positive, this is negative. So here's how you break down the formula. Here's how you factor using this situation. In this circumstance, the pattern is a plus b squared. In this circumstance, the pattern is a minus b squared. And you get that a and b by square rooting the first term and the last term. So in this first example, factor 4x squared plus 24x plus 36. So when you factor the first thing, you get 2x. You factor the last thing, you get 6. Okay, so that's going to go here, 2x. It's going to go here, 6. To decide on the sign, it depends on the sign between the first two terms. If it's a plus, then your answer is going to have a plus. If it was a minus, the only thing difference is your answer is going to have a minus, and that's it. If you FOILed this out, because squared means 2x plus 6 times 2x plus 6, you'd get this back, because you'd have 12x twice, which is 24x. And then over here, how do I figure out what a is? Square root the first term. What's the square root of 9? And the square root of x squared. Okay, so that's my a right there. That's going to go in the a spot. And to find b, you square root that last term, the 64. And you have 8. So that goes in the B spot of the formula. And it's a minus because this problem had a minus right here. So our answer has to have a minus. But and then a squared. That's exactly right. So try those last two problems on the bottom to see how you do with the formula, and then I'll give you a worksheet and we'll be good to go. We're good to go. So try A and D. Neither one of those has a GCF, by the way. So just follow the formula straight. On A, by the way, you can do any of these problems with our other method, with the cross thing, okay? But today we're just practicing these special shortcuts. You square root the first one. You square root the last one. What do you get when you square rooted the first one? 1x. Square root of 9 is? Does this need to be plus or minus?
Plus.
Right, plus, because that's a plus, and so then it's squared. So that's that. So everything I'm going to give you, it will work. I'm not, well, let me finish this and I have one more thing to say about that. Because well, on this one, it's just 2x minus 11. So this one isn't the plus and minus version. The plus and minus version is only when you have two things being subtracted, not when you have three things. See, that's the trick about these things, is being able to recognize when to use them. It's almost why I don't even like, I kind of don't even like teaching them in the first place. Except this one. This one's really useful. If you did the crossing, you'd get the exact same answer. Yep. Mm-hmm. It's just a longer process. That's exactly right. So if you were able to recognize the situations, the shortcut would save you time, right? But if your brain, if that like is too hard to recognize when to use it, you can always do the cross thing. You're looking for perfect squares. Also, though, this middle term has to be the square roots doubled, right? So let's do this one. So this gives you 2x, and this gives you 11. And then you have to subtract them, right? Because that's a minus. So here's the pattern. 2x times 11 is 22, right?
Yeah.
Times 2 is 44. You would have to be looking for it every single time. So here's the thing.